Hello and welcome to Design a Container Build Strategy. I'm Andrew Conniff, a Microsoft technical trainer specializing in data and AI, and today we will explore how to design and implement a container build strategy. Let's dive right in. Containers have revolutionized application deployment by providing lightweight, portable environments that run consistently across different platforms. Here we're going to introduce the concept of container build strategies and why they are essential for modern DevOps practices. So, a container build strategy defines how container images are created, tagged, and stored. It ensures that builds are reproducible and secure, leveraging tools like Docker and Azure Container Registry, and this approach simplifies deployment pipelines and accelerates delivery cycles. Containers are a modern solution for running applications that offer several important advantages over traditional virtual machines. First, they're highly portable, meaning you can run a container anywhere Docker is supported, whether that's on your laptop, a cloud server, or a data center. Containers are also consistent. Developers and operations teams can be confident that the code inside a container will behave the same way no matter where it's deployed. Because containers are lightweight, they use much less disk space, CPU, and memory than virtual machines, making them efficient for both development and production environments. Virtual machines run applications on separate operating systems, so each with its own operating system instance inside of it on top of the hypervisor. This means that VMs are heavier, using more resources because every virtual machine includes a full operating system and virtualized hardware layer. Containers, on the other hand, share the host operating system and run isolated applications using a container engine. So they're more lightweight, they start quickly, and use fewer resources since they don't need a full operating system for each instance, just the application and its dependencies. So virtual machines are best for complete isolation and running different operating system types, while containers are ideal for efficient, consistent app deployment across environments. Docker containers make it simple to package and run applications consistently across different environments. The process starts with Docker build, which creates a container image from your application's code and a set of instructions, the Dockerfile. And this image is like a blueprint, capturing everything your application needs to run. Once built, you can use Docker pull to retrieve the image from a container registry. So think of that as downloading a ready-made app package from a secure online store. This is especially useful when you want to use images created by others or deploy your app across multiple machines. Finally, Docker Run brings your container to life by launching an instance of the image as a running application. If the image isn't already on your system, Docker Run will automatically pull it for you. So this workflow, build, pull, run, enables teams to develop, share, and deploy applications quickly and reliably, whether for development, testing, or production. By mastering these commands, you can streamline your software delivery and ensure that your apps work the same way everywhere. Containers are often created using a Docker file. This Docker file creates a simple container image based on Ubuntu. It sets a maintainer label, adds the contents of app setup directory to the root of the image, and runs a shell command to source the user's bash and print the home directory. Finally, it specifies a default command that echoes hello world from within the container, and the container starts. This setup demonstrates the basic structure and instructions needed to build a custom Docker image for running an application or a script in a consistent environment. This Docker file demonstrates a multi-stage build process for a .NET Core application. It starts by defining a base image for running the application and then uses a separate build image to compile the application. The process includes restoring dependencies, building the application, and publishing the output. And finally, the published files are copied into a final runtime image, which is much smaller and contains only what's needed to run the app. This approach keeps the final container lightweight and secure by excluding unnecessary build tools and files. So the important thing to know here is that each from statement is cached, but only the last one is the one the image is created from. This allows the final image to only include those items needed to run the application. When creating multi-stage Docker builds, it's important to adopt a modular approach. Break our container into logical stages, each with a clear purpose. Avoid including unnecessary packages in our final image, and only bring along what our application truly needs. This keeps our containers lightweight and secure, And the most important step is to choose an appropriate base image for each stage, as this impacts both the size and the security of our final container. Also, make sure not to include application data in our build images. Keep our images focused on code and dependencies, not on environment-specific data. Azure offers a suite of container services designed to simplify how you build, deploy, and manage containerized applications. With Azure Container Instances, you can quickly run containers in the cloud without worrying about managing servers or infrastructure. Just focus on your application. Azure Kubernetes Service, or AKS, is the go-to solution for orchestrating and scaling containers, making it ideal for complex, production-grade workloads. Azure Container Registry provides the secure central place to store and manage your container images, while Azure Container Apps lets you build and deploy modern microservices using serverless architecture. For web applications, Azure App Service delivers a managed platform with both Windows and Linux apps, streamlining deployment and scaling. The main benefit of these Azure Container Services is that they help teams move faster and operate more efficiently. Developers can focus on writing code and delivering features, while Azure handles the heavy lifting of infrastructure, security, and scaling. Whether you're running a single container or orchestrating hundreds across multiple environments, Azure's container ecosystem provides the flexibility and reliability needed for modern DevOps and cloud-native deployment. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.